All right, so we're going to work a couple of examples with the quadratic formula. We're going to do a couple of different types of things, get different types of answers. Most of this we're going to do completely without a calculator. We may, well, on this one we're going to go no calculator, period. Yeah, that's pretty good. So let's go ahead. Remember, quadratic formula works from standard form. So the first thing we need to make sure is that we are in standard form. So ax squared plus bx plus c equals 0. So it's got to be equal to 0. You've got to have a quadratic equation. That's what we do have here. Please note that I do not have a term that just has an x. Deal with it. Okay, so now let's go ahead. Let's list down a. A is the number that's in front of the x squared, which just happens to be a 1. If it's not there, we understand it's a 1. All right, b is the number in front of just the x. Now in this case there's not 1. The only number that could be then is 0. So we make b equal to 0. Next we got c. C is the constant that's all by itself, which is 16. So from this point we can go ahead and we can do our quadratic formula, which is x equals negative b plus or minus square root b squared minus 4ac all over 2a. That's right, so we're going to go ahead and put these in. So x equals negative 0 plus or minus the square root of 0 squared minus 4 times a, which is 1, times c, which is 16, right? All over 2 times a. We simplify this. We say x equals 0 plus or minus the square root of 0 minus, let's see, negative 4 times 1 is negative 4 times 16 is negative 64 over 2 times 1, which is 2. We now find that x equals now 0 plus or minus. You're adding or subtracting 0, so it's really just plus or minus the square root of 0 minus 64 is negative 64 over 2. At this point we say, it's the square root of a negative. Now square root of a negative is bad because at this point we don't know how to do that. The fact of the matter is that it's not real, it's imaginary. I know you're saying, well, if it's not real, of course it's imaginary, Mr. Bauer, but it's real imaginary, if you know what I mean. So yes, at this point we're just going to say no real solutions. Okay, just to further prove my point, because I know some people are going to say, oh, but what about negative 8? Well, negative 8 times negative 8 is a positive 64. It's not a negative 64. And then inevitably I get, well, what about negative 8 times positive 8? Well, yes, that gives you negative 64, but that is no longer a number times itself, which is squared. So anyway, yes, no real solutions there. Sorry about it, but yes. The quadratic formula does always work. You will get the answers. They're just not real. Okay, so let's go on to our next question. 5x squared minus 8x equals 6. Again, first priority is that we get it in standard form. Ax squared plus bx plus c equals 0. So that 6 has got to move. We've got to move it over. We're going to subtract it, because if I subtract 6 from 6, I get 5x squared minus 8x minus 6 equals 0, right? And so there we go. It's now equal to 0. Now I can do the quadratic formula. A is 5 because that's the number in front of the x squared. B is negative 8, which is the number in front of the x by itself. And then we got the c, which is the constant that's all by itself. It's minus 6. So now we can go ahead and we just plug those things straight in. So x equals negative b, which is negative 8, plus or minus. Now I write out the negative 8. If you want to just put positive 8, that's fine, but if you make a silly mistake, that's not my fault. I told you to put it in parentheses. So negative, then put b in parentheses, then I put the b squared in parentheses too to make sure I remember that's a negative 8 squared. So b squared minus 4 times a. I always put these variables in parentheses because that makes sure that I don't make silly mistakes later. I'm not going to forget and subtract the 6 or something dilly-winkle like that. So 2 times 5, which is then the bottom, 2 times a on the bottom. So I've just replaced each of those variables. I haven't done anything hard. It's just a little bit different. So here we go. We now simplify. Negative 8 is a positive 8. plus or minus the square root of negative 8 squared is 64. Negative 4 times 5 is negative 20 times negative 6 is plus 120. If you can't do that in your head, do it on your paper. It's still not that bad. You don't need a calculator for that stinking stuff. 2 times 5 is 10. We'll go ahead and simplify a little bit further. X equals 8 plus or minus the square root of 184 over 10. Now at this point, I don't know what the square root of 184 is. If you do, congratulations. But I'm going to go ahead and go over here to the side, and I'm going to do a little bit of thinking. And in this thinking, I'm going to do square root of 184, and I'm going to try to simplify that. I know that 2 goes into that. 2 goes into 184 92 times. And 92 has a 2 in it as well. That's 2 times 46. And 46 has a 2 in it as well. That's 2 times 26. And so what I'm going to go through, and I'm going to find the pairs. So I've got a pair of 2's here. So if I write this out, this is the same thing as the square root of 4 times 2 times 26. And not 26, sorry, 23. That was close. So 23. All right, so that's as far as we can go. We take the square root of the 4, which is 2. We can't take the square root of the 2, which means it stays inside. Can't take the square root of 23, so it stays inside. So I replace in my original equation now x equals 8 plus or minus. But instead of square root of 184, I'm going to write 2 root, and then this is 2 times 23, which is 46 over 10. At this point, you want to reduce what you can reduce. So x equals, it looks like they're all divisible by 2, so we reduce by 2. So 4 plus or minus the square root of 46 all over 5. There you go. That's as far as you need to go as long as you're just simplifying. If you need a decimal answer, you can plug that straight into your calculator. You can get it. But remember to put the top in parentheses so it does the adding and subtracting first and then the division. You'll have to do it twice. Once for the addition, once for the subtraction. We're done.